hyperlocal identifiers. That creates an additional problem when you need to connect or share the data. And the data models themselves, they're buried in the implementation layer. They're separate for each application. They're not shared. And to get that, you need to have some kind of interpretation, some kind of interface, which needs to be changed again when something changes. But we keep talking about big silos, forgetting that there are also small silos, like spreadsheets. And I keep repeating that spreadsheets like plastic packs. They're convenient and multifunctional, but they're not reusable and they severely pollute the information environment. I still also use spreadsheets, although I'm trying to avoid it. I also try to avoid other small silos like documents, unless they're for exchanging data. Here you see I'm presenting not from PowerPoint, again, because it will be putting a data in a silo. But basically, big and small silos, they lead to no interoperability, very high cost of change. In most cases, big silos, they're based on SQL databases and changing something. So imagine somebody decided to put a single value and has to be multi-value. That would need a new table. All the queries and all the indices should be changed. That normally goes for about 6 months and it's very expensive. Not to mention more serious changes when the legislation is changing. So the third thing is also a high cost of integration. And these are the problems that this thing is addressing. Of course, they can be addressed in other ways, but here there are certain benefits related to not having vendor lock-in, high reusability, and very low costs and high flexibility. So what is linked data? The shortest way I could explain it is that it is a universal approach for naming, shaping, and meaning of information. So naming is done by using uniform resource identifiers. The good thing about that is that everywhere, regardless of the context, they would represent the same thing. At the same time, different publishers, they can use their own. It doesn't need to be unique as long as they're unique for certain publisher. There are ways to link them. That would mean in practice that if you want to go this way, everything that represents a resource needs to have URI, everything from all the databases, all things that are there, which is, as you know, not the case currently. Then the other is shaping. Everything is a triple, something created subject, property, object. And the nice thing about it is that data, metadata, validation rules, they're all with the same shape, the shape of a triple. And you can add more, you can change things, and that happens always the same way. You can get one graph from one place, put it in another, it will work the same way. And that is the beauty of it. And the third is the meaning. So meaning is explicit. It does not depend on some application to interpret it. So it uses shared semantic models called ontologies, and they have additional benefits that they follow certain logical axioms. And now there is a whole movement around that discovered there are billions that are wasted in big enterprises, because normally linked data is very much linked open data practice. But this movement discovered that there is a huge waste of IT investments in unflexible information systems because of this application-centric mindset. And they came up with this data-centric principle, saying that data is a key asset. It is self-describing, does not depend on something to interpret it. It uses non-proprietary formats, and the access to insecurity is the responsibility of the data layer. Applications should work as views, and that is also something that the new Solid movement tries to create as an ecosystem. You can find this at the Data-Centric Manifesto. It was launched a couple of months ago. It has already over 1,000 signatures from quite big organizations. What is happening with linked data in the European institutions? Well, quite a few things, yet not much. One of the leaders in this area is the Publications Office with data portals. All the European legislation metadata is available through Seller and so on and so on. Recently, there was one new project that you don't see here, Cohesio from Regio. If you don't know it, I would strongly advise you to see it. It's something quite impressive, done only with open source solutions. And here's the new kid in the block, European Agency for Railways, ERA. I'm saying here because it was a pilot and now it's moving to production. But of course, I'll show you only what was in the pilot. So what is that agency? That is an agency associated with the DG for Transport. It was established in 2004 to devise a technical and legal framework for creating a single European railway area. Up until recently, the core activities were creating a harmonized approach to safety, and safety is quite a focal topic for them. Removing technical barriers, advancing the single train control and communication system, ERTMS. Maybe some of you have heard about it. And promoting simplified access for customers for the European railway sector. And then there was a new directive in 2019 that extended the mandate with a few more activities, but it also gave a lot of additional requirements, and this pilot is responding to these additional requirements for one of the registries that the European Agency for Railways maintains, called RINF, that maintains the railway infrastructure. It's interesting in this situation that even in this small pilot, there are plenty of stakeholders with their understanding, view, and way of managing data and depending on each other a lot. One of the key for the pilot were infrastructure managers, those that are responsible for the railway infrastructure. The other were railway undertakings, so those are responsible for operating whatever rolls on this infrastructure. The term for that is a rolling stock. And there are vehicle manufacturers that they only registered vehicles approved by ERA are allowed to roll on this network. There are wagon keepers. And to make things a bit more complicated, you cannot provide data from infrastructure managers directly. Each member state needs to appoint a national safety agency, national registration entities to register that data. And apart from that, they have also additional structures, national safety agencies. So there are hundreds of manufacturers, and for all the rest of stakeholders, just have these bullets and multiply them by 27. So there are 14 or 16 registers that by law European Agency of Railways needs to maintain. This is their list. They're all databases. Most of them are just regular SQL databases with a few exceptions that are a bit, let's say, less standard ones, but still following this paradigm. And they, of course, all data silos, which is a bit of a pity because one of the core requirements for the railway agency is to be responsible for interoperability. And they realize that, that's why we are having this thing. So the pilot wanted to see if linked data could be a good approach to solve the different interoperability problems. And it started last summer, so it was about 7-month project with a very, very small budget and just a few people team. The idea was to show interoperability, but with something additional that is in demand, wasn't achieved so far, and is currently not available and couldn't be available with the way things are structured, and that is the root compatibility check. And that is quite of a paradox, because it seems that in order to show a data-centric approach, you still need to do an application. And that is actually an application working on top of the knowledge graph. So basically, what it does, it works on the main interface between the topology and what is rolling on it. These are the tracks. So when you can choose a route from A to B, there could be several different routes. They go through things code operational points, and with different sections of lines that they have different technical parameters like gauging, vertical radius, wheel set, and many more. There are about 40. Similar or the same kind of technical parameters are for each of the registered train vehicles, and there are thousands. So they're in a different register called error TV, and the idea is if we select a vehicle, can it go from A to B? And if not, why? So to give you some idea how does it look, let me show you from the graph something actual. So let's just see one. So these are nodes from the graph, just to see how the parameters look. So you see we have these edges that are representing certain parameters like energy supply system, gradient profile, and here are the values. So for all the tracks in the whole network, these are represented, and then in a different way, they are presented in vehicle types. And apart from the vehicle types, there are, of course, vehicles of these types that are in a different register, and I will explain this a bit later. So the data sources for the pilot were four. Of course, the end idea is to have a full semantic layer to cover all the registries maybe in a few years, and they should be experienced as one database. The data sources for the pilot were the railway infrastructure inf, the error TV, that is the vehicle types register, the actual vehicles in a different register, and the wagon register. Something about RINF. It was again responding to a directive in 2008. That's why everything there is regulated. It's something that needs to be maintained by law. In terms of the main entities, we have operational point, section of lines and tracks. Operational points is where the tracks changes. Section of lines is these things between that have different parameters, and each section of line has one or more tracks. The tracks actually the physical part. I'm not going to go to all these details. And of course, this is a very high level thing. The actual picture is much uglier than that. Yeah, as you can imagine. And then we have the error TV, where we have these parameters for in a different way of encoding for the vehicle types. And these are the two other sources. I'm not going to go through them to explain. What is a knowledge graph basically? I'm not going to go to the details, just to maybe very quickly that the two types, one is the property graphs, the other is the semantic graphs. With RDF, we're going to talk about this, the semantic graphs. The access can be open or closed. In this case, will be mostly open. And there as users, you have public knowledge graphs, enterprise knowledge graphs, and personal knowledge graphs. In this case, I'm using a personal knowledge graphs to make this presentation. So in order also to walk the talk, currently you don't see slides, you see actually facets of my personal graph, and everything that you see as bullets or images are nodes with URIs. What you see in the slide as block or nested block or image are also nodes of my graph. So what is actually digital transformation in terms of going into semantic knowledge graphs? Well, it includes the following thing. It includes to move several steps from hyperlocal identifiers to hyperlinks, these URIs. Then, as you know, in the relational databases, although they're called relationals, the relations actually do not exist. And to be realized, you need a table of associating keys from different other tables. They're not a first-class citizen. For LPGs, they become a first-class citizen, but then you have from one side ambiguity whether to do something inside as attributes inherited as principle from the SQLs, or in a different way. So if you bring a few different graphs, they will not work together, not to mention that each different GraphDB has its own language. And here everything is based on open standards. And the third transformation is to go from implicit and local semantics to explicit and global semantics. When doing so, different things are revealed. In this case, for example, immediately huge amount of quality issues were shown. Like you see, for example, RINF user guide shows that you have this way of representing energy supply systems. And at the same time, from these databases, we get a lot of different values for actually the same kind of energy supply system, because for different reasons, it could be typos, it could be another reason. And then in going to RINF, things were even worse. There were a lot of disconnected operational points, over 2,000 in the whole network. Well, a lot of other issues. Doesn't show the actual. So this is a node, and tracks are going in and out, but doesn't show actually where this could be realized because it doesn't have this level of detail. So, and the knowledge graph that was produced, it has over 30 million triples only from these 4 data sources. So if you see them as, you'll see them in a while as a graph, but now if you see them just as vectors, so imagine each point here is with 3 coordinates, subject, predicate, object, it would look something like that. This actually represents this 13 million. And in a while, you'll see it as a visual graph when we go and yeah. So the ontology, it has 2 layers. So the ontology is a simple way to represent all the semantics, and in a shared way, it's not anymore in the physical schemas of these databases. It has 2 layers, abstraction and implementation. And in the abstraction layer, it is important for root calculation, and the implementation layer is important for the actual compatibility check. Maybe to show you how it looks. You can go, everything is open, you can play with it yourself. So this is the ontology. That's a bit cheating because it doesn't show all the details. But even when you show all the details, like I'm doing now, still it is much simpler than the combination of the schemas that appear, not to mention how it is reusable and that you can add new data without an issue to it. You can go see what this is fully documented. This is just a visual presentation. And that's a bit of a statistics where is the biggest number of instances. They're in this called internal node link. And that's solution architecture. Well, we'll go in a while to the solution architecture. Now let's see the actual application. It uses RDF streaming. And in fact, when you go around and you zoom or pan, these operational points will start appearing. These are again nodes of the graph. Some of you know that although this is a great paradigm in terms of interoperability, it's inefficient in terms of data storage. That's why there are special measures that needs to be taken when such complex tasks are solved. And in this case, these special measures are realized through graph partitioning. So only the part that is needed is actually queried and put in memory. And there is a very smart tiling approach that is realized for that to help people understand and see what is behind. What we created is a help page. So here you can go and see yourself what is going on. And in every part, there is a part called under the hood, so that people with more technical interest can see what is behind. They can, of course, also use the browser inspect function and see how things are streamed from the graph. So let's actually now show what the application does. I'll zoom somewhere. So here, select this starting point in Netherlands, close to Utrecht. And you see now it's the tile calculated and all the data from that tile is there. And here we have this from Vutten. Then I will find something which is in another country because it is more interesting when it crosses the border. There, the biggest interoperability problems appear. So let's choose something in Düsseldorf. I need to bring in, of course, there are many operational points that will not be shown unless I zoom completely. And so I've chosen another point as endpoint. And now all the tiles that I needed from the graph are calculated that are between these two nodes to find all operational points that are between following the shortest path. You can also ask for several paths. This is just finding one path, one route. Now, if I expand the route, you'll see the actual operating points depending how much it's possible to see from the zoom level. Now, what you see on the left, it looks just like a list, something like you would see also in Google if you choose, but there is a big difference here. What you see is actual path between nodes of the graph, and this is just one possible use of that. You could add many other uses without making sophisticated changes or changes at all. Here what you see is the operational points between is the track. Everything here is a node in a graph. I'll show you in a minute. Now we have these 41 operational points with track between them, for which we have all the technical parameters loaded. And now what is actually application doing is if you choose some kind of a train. So of course, from the register, the data is what it is. And for some vehicle types, not all parameters are maintained, unfortunately, yet. So here is what we have here. From this point to that point, if we choose one route, it has these 40-something operational points, the tracks between them. And if we want to ask if this particular vehicle type can go there, it will show that in many parts of this track, it cannot go, and it will show why. Here is incompatibility for the gauging profile. Again, what you see here as links are also nodes in the graph. And this is coming directly from the ontology and can be reused for many other purposes. It's just one way, because when you see this table, and for many people just seeing such an application, they would not understand what is the huge difference between having that and using a semantic knowledge graphs behind. That's why I'm trying to, in fact, if you want to interact with the data directly, in this case, the only thing you need to do is to click on any of these. So they would be either edges like this, or they could be values. Some of the values that are clickable, they're reference data. And a huge problem for them was they didn't have, and still don't, a proper reference data management. I'm very happy that recently the policy for reference data management was introduced, and as far as I know from Willem, it was endorsed by the IMSB last August, I think. That is extremely important. There's a huge mess that would not be solved until we do a proper data governance, and an important part of data governance is the reference data management for any organization. Here, for the European Railway Agency, luckily, because of this part, they realized that. So using these two data sources, they realized that they have about 30 data sets that are not properly managed as reference data. They started doing so, and now there is the first attempt with sort of project-wise managed reference data, still not properly done. It needs much better governance to really, but all these things are now the first step of managing reference data. So if you see things like gauging profile and axle bearing, all these things that on the right as value have something clickable. The fact that it's clickable means that the value is URI, and because of that, it's something that is an integration point. So these kind of values, they were encoded differently in different registers, and now they're a single node in the graph, which means that this kind of value would link to all tracks that allow this value and to all vehicle types that have this value as a technical parameter. So that would be a compatibility case. And you see this going on below. Now let's click on one of these nodes. Let's say on the first row. Doesn't matter. You can do that yourself. Maybe choose a more interesting one, which would be the Utrecht itself. Now here is an important point. The important point is, in order to demonstrate that there is a zero vendor lock-in, this application is made to work with three different backends. Currently, I will show you the graph in one free GraphDB database that is maintained in our partner at imec. Then I will show you the same data with our graph in Digit that is maintained in Virtuoso. I will not have the time, but you can play it. And there is a third, using a third paradigm of managing graph that doesn't use this kind of triple store, which is the linked data fragment. All these are maintained, and switching between one and the other is trivial. And that's a very important point to make, to show that this way would guarantee a complete independence of the strategy and fate of any software vendor. So what you see here is just a table representing that, but I guess it will be more fun to see the graph. So that's the Utrecht Central, and we can go and start walking the graph. Here it's a micro node, the next part, and that is the node it belongs to, where you can see different parameters. So we can go and find. Now you see also the type of everything. If you remember, the table showed it just as a value, but here, in fact, it is even this thing is also a triple. These are two separate things. So you see that node and the type of that node, which is so from one side it is as a type is an operational point. This is hidden here. It's not shown, but it's another triple. And another triple shows that the type of this operational point is a passenger terminal. Of course, if I now click, here's one example of using reference data, and not reference data maintained by the railway agency, but it's actually an official reference data. I mean, it's not that the railway agency data is not official, but they still don't maintain it properly with control vocabularies. So what here you have is in country. This uses the authority table of the publications office for all the countries. And that I would recommend for anything that is already available. There are quite a few authority tables and other ways of collecting reference data that reusing that would increase interoperability tremendously. If we do something similar, this is the application, but configured to use the other graph. So this is the new route. Yeah, it has much more points, like 90. But here it uses the graph on our data platform. So if I go to a track, or I can go to the respective vehicle type, this one. And again, it calculated for all the operational points the compatibility. Now, if I go to the vehicle itself, again, this is a node in the graph, but you'll see entirely different performance. So if I walk the graph this way, for example, let's use something that we used already, the gauging profile. So here is a vehicle type having this gauging profile. Now, if I click, it will open the node and the graph and show on the opposite way who else has this gauging profile, and this will show all the vehicles, but also all the trucks. So if I go to the end, that would show trucks having the gauging profile, and of course different parameters. And we can now keep on clicking. This is all open. You can play with it. You can discover interesting things. It's now available. The other interesting thing is that when you go inside, the operational point does not show exactly how the trucks are connected. There are several trucks going in, several go out, but you don't know which routes are possible outside. Maybe it's better to show it here with Utrecht because it will have more points. And that's why we just threw another data set from ProRail, which is an infrastructure manager of Netherlands. It added this level of details, which you see now here. And in a few remaining minutes, a few things about the architecture. This is the root compatibility checked, which is a React application. And there is another component, knowledge graph querying. It uses just a web application server because the certain geotasks are not so well performed by Sparkle, like the shortest path, and it uses normal querying, but the Sparkle is used to get all the data in memory. And here you see that this component called ERA GeoLDF can use as backend Virtuoso, that small server that I showed you with the visual representation of the graph, and also something that is not even a triple store, but different kind of storing RDF, which is another important message, that RDF itself is a conceptual way of managing data, and the storage behind could be a triple store, could be something like MongoDB or Elasticsearch, it could be GraphDB like Neo4j or Neptune, it could be even a normal SQL database if it is structured the right way. So it's not a matter of storage paradigm, it is a matter of data management paradigm. And many people see it as a format or something special associated only with triple stores. That's not the case. That's very important to understand. And it was important to demonstrate it here as well. And here we have the data sources. The data sources, I told you, these 4 data sources. The important thing is that not only querying, storing, all these things are based on open standards, but also transformation from non-graph to graph is based on open standards, and it's easily reproducible. In this case, RML is used, RIDF markup language. Mapping language, sorry, that is in fact a superset of R2RML, a standard of W3C for transforming tabular data to RDF. And here you see this is entirely realized with open source components to produce the knowledge graph. Of course, in the pilot, it was just a matter of once of producing, but now going into production, we are going to do that in real time. And that would also bring another level of complexity related to previous versions, for which we would use something quite new, and that is linked data event streaming.